Hi friends, welcome back. In today's video, we'll be looking at deriving some rules of derivatives. The first to look at is the chain rule. Okay, so the chain rule is applied when we want to find the derivative of a function whose variable itself is a function. So it could be, an example could be d by dx of f of g of x. That function f has g of x, which itself is a function as a variable. So assume g of x is r, okay, and we can rewrite this as follows: d by dx of f of g of x. Now that equals d by dx of f of simply r. Okay. Now we have d by dx of f of r. This is equivalent to d by dx of f of r times dr by dr. So we can do that because we're just multiplying d by dx of f of r by 1, right? So there's no change in the total meaning of the original expression. So I can then rearrange this as follows: f of simply r. Okay. d by now dx, we have of f of d by dx of times f of r. This is equivalent dr to by dr can be rearranged as follows: dx of f of r, d of f of r times dr by dr times. So we can do that because we just multiply dr by dx, d by dx of f of r. So we just change it 1, right? So there's no position of this. In the both of them are divisors, so it's possible to change their original positions without altering the meaning of the original expression. I can then now rearrange substitute this back simply r. Okay. d by substitute back dx, we have of f of d by dx g of x of times f of r for r. This is equivalent dr to. So we had by dr can be rearranged as follows: dx of d by dr of r of f of r by times dr times. So we can do that because dr by just multiply dr by now if we then substitute back g of x in place of r, change it, so we'll have d by the position of this. In the both of them are divisors, so it's possible to change the original of f of without altering the meaning of the g of x original expression. I can then now rearrange substitute back times simply r d by dx, d by substitute back dx of g of x. We have of f of d by dx okay. G of x for times f of r for r. So therefore we have derived the formula for finding the derivative of d by d of x, d by dr of f of r by times g of x dr by dx. So this equals, now if we then substitute back d by x in place of r, d of g of x, so we'll have d by the d of f of g of x change the original of f g of x without altering the meaning of the g of x original expression times. I can then now d by d of x simply r. of g of x, d by dx. Okay, substitute back. So this was what we're looking for. We have d of x times for r. So therefore we have derived the formula for, so we call this finding the derivative of d by d of x, the chain of f of r times g of x dr by. The next rule we'll be looking at is the quotient rule. The quotient rule, as the name indicates, is when we try to find the derivative of ratios between two functions. This would be d by g of x dx g of x of times f of x d by d of x over of g of x. Dx. Okay. So we'll be looking at deriving what the derivative of this expression would be. Now we'll try to look this and apply the first principle of derivatives given us in the following. Here I'll just be giving you the expression for the first principle, d by dx. The next rule we'll be looking at is the function of f of x. Function f of x. The quotient rule, as the name indicates, is when we equal to the limit derivative of ratios between two f of functions, x plus some small change in x of times minus f of x d by d of x over g of over that small change x. As the change in x approach to derivative of 0. This expression. So now we'll try to look this. What this equation or expression is trying to say is derivatives. We're trying to look at the change giving you of that function when there is small change in its variable. So the rates of the change of the values is when there is a small change, sigma x, that sigma x approach to 0. So this would be the small definition of derivative of a function minus f of x. So we'll be applying this over that small expression to find out what the derivative approach to the ratio between these two functions is. So okay. Now, right. What this equation, so now is trying to say is applying this will mean the change d by dx of that function when there is small change in its variable. So f of x of the change of the g of x is when there is a small change is therefore sigma x. That sigma x the limit to 0. So this would be the small definition of derivative of a function of f of x plus small change in x, this over g to find x plus the derivative small change in x the ratio between minus function f of x, okay, over g of x. So now is trying to say is over applying this will mean the change d by dx of that function when there is small sigma x sigma x of the change of approach to 0 g of x. Okay, when there is a small change is therefore sigma x, that sigma x the limit to 0. Now let us concentrate on the numerator part of this expression. So that is f of and try to rewrite or re-express it in simpler form. F of x g x plus sigma x over g of x plus sigma x minus f of x over g of x. So this is difference of two fractions. So I can rewrite this as g of x and g of x plus sigma x as as a common multiple for its denominator, and then so the way it goes is just divide this by the denominator and multiply it by the numerator. Okay, so that divide by the first will be, you remain with g of x and multiply that with the numerator. So for the first you'll have f of x plus sigma x times g of x minus, and for the second you'll have f of x times g of x plus sigma x. Okay, all right, now again let us concentrate on this part. So what we have is f of x plus sigma x gx minus f of x times g of x plus sigma x. So that's what we have here. All right, so if I add f of x g of x subtract f of x g of x, so it's as if I have done nothing. So I'll add f of x times g of x here. I will again subtract f of x times g of x here. So it's as if I am adding 0 without again changing the meaning of that original expression. Okay, so then if I now bring f of x plus sigma x gx now minus f of x g of x, so it's that expression that I brought forward here. Okay, now minus, I'll keep this expression now, bring this expression, okay, minus f of x g of x plus sigma x plus, I'll bring this expression here now, last, plus f of x g of x. Okay, so let's concentrate on these ones. If we group those two together like this, okay, let's find a common factor here. That will be g of x, so g of x can be factored out, g of x, and will be remaining with f of x from here, and to f of x. Okay, so that'll be f of x plus sigma x and minus f of x here, minus f of x. All right, and from this side f of x will be a common factor. So if we take now minus f of x as a common factor, so we'll be having g of x plus sigma x, g of x plus sigma x, and minus g of x, minus g of x. Okay, So that minus times minus will give you that positive plus sign here. Okay. So now that expression, remember, we did that to actually rewrite the numerator part of this expression here. All right. So we can plug it in back again. So if we plug it in back again, what would you have? You'll have that equals, okay, g of x into f of x plus sigma x minus f of x minus f of x times g of x plus sigma x minus g of x, the whole over this expression, which is g of x times g of x plus sigma x. Okay. Now again, the whole expression that was to simplify that top expression, and then we can substitute the whole of that into our limits. So to find the derivative of f of x over g of x, equals the limit as sigma x approach to 0 of that expression over sigma x, so which is g of x times f of x plus sigma x minus f of x minus f of x g of x plus sigma x minus g of x. So that over g of x times g of x plus sigma x, which directly comes from this, times sigma x, which comes from this definition of the derivative. Okay. All right. So, all right, we can take out the limit of that alone, right? So we can rewrite this as follows. The limit as sigma x approach to 0 of 1 over g of x times g of x plus sigma for that part, okay, times, we can then take out g of x because that's not influenced by the variable change of x, so that will be g of x times the limit as sigma x approach to 0 of the rest expression, which is f of x plus sigma x minus f of x, okay, over, so now that sigma x, can be a denominator for both of expressions. It can divide both of expressions, so we can bring it here over sigma x. Yeah. Okay. Now minus minus, right? So that minus is that one there, right? So minus, and we still can take out f of x, as that's not influenced by the variable sigma x. So same way, f of x can be taken out of the limit. So limit sigma x, as sigma x approach to 0, of the rest of the expression, which is g of x plus sigma x minus g of x, okay, on there, over, now as we have said, sigma x can divide both sides, so over sigma x. Okay, now we have simplified it, okay, so because the limit as sigma x approach to 0 of that expression equals 1 over gx squared, so that will be, as the limit change of x approach to 0, that will be 0, and we'll have gx times gx, which is gx squared, okay, times, and that gx is, again, as we've said, not dependent on sigma x, so that will be g of x. And now, as we have defined here, so if you see that part only, this part, so that will be the definition of the derivative of f of x. So that will be f of f prime of x. Let's that stand for derivative of f of x. Now minus, okay, minus, and again that will stand, f of x will stand alone, f of x times that limit, that entire expression is the definition of, again, the derivative of g of x. Now, so that will be g prime of x, and let that stand for the first derivative of g of x. Okay, so therefore we can now summarize that the derivative of dy dx of f of x over g of x equals g of x times the derivative of dy dx of f of x minus f of x times the derivative of g of x, okay, over g of x squared, g of x squared. Okay, all right, so that is the derivation of the quotient rule. All right, the last rule of derivatives we'll be looking at today is the product rule. So if you want to find the derivative of product of two functions, you'll be using the product rule. So that can be written as follows. So let's have two functions, f of x and g of x. So the derivative of their products with respect to x, f of x times g of x. Okay, so this is what we want to derive. We'll make use of the first principle of derivative. Let's try to remind ourselves the full expression of the first principle of derivative. Function, the first derivative of a given function is the limit of f of x plus sigma x minus f of x over sigma x as sigma x approach to 0. Okay, now again, armed with this, our given function can be written as follows. So d by dx of f of x times g of x can be written as the limit as sigma x approach to 0, f of x plus sigma x times g of x plus sigma x minus f of x times g of x over sigma x. Okay, now let's be interested again in this part and try to appropriate in a way that can help us reduce the expression. Okay, so if we consider the above, consider the numerator part of this function, which is f of x plus sigma x times g of x plus sigma x minus f of x times g of x. Okay, so if I can take that expression, okay, and let us add now f of x, this following expression, f of x plus sigma x times g of x plus sigma x, okay, minus, again minus, okay, I'll continue here, minus f of x plus sigma x times g of x plus sigma x. Okay, so what we did is we added some expression and subtracted the same expression, so without changing again the meaning of the original expression. Okay, now rewrite this in such a way: f of x plus sigma x g of x plus sigma x. Okay, now I will take this and put it here, minus f of x. Let me use a different color so we can differentiate which one is which one. So f of x plus sigma x times g of x plus sigma x. Okay, and let us bring this again now. So plus, okay, let's bring this expression, f of x plus sigma x g of x plus sigma x. Okay, again minus, let's bring this one again, so minus f of x times g of x. All right, okay, now I'd like to group this into two groups. First is this group here. The second is the other group there. Now we need to be reminded that sigma x is infinite small number, so very small number, which actually approach to 0. So in that case, we can make the following assumption. So the assumption I'll be making will be f of x. So let's just rewrite with that assumption, f of x plus sigma x times g of x plus sigma x minus. Now what I can do is f of x, okay, I can omit this because sigma x is so small, so I can choose to do that, f of x, and then keep the other f of x, g of x plus sigma x. Okay, plus I'll go on again, write this f of x plus sigma x times g of x plus sigma x, now minus then this time f of x, I will add that small sigma x here. Okay, so as far as that is a very small number which approach to 0, then I can choose to do that, times I'll keep the rest g of x. Okay, all right. Now let us now bring common factors out. So I can have, from this side I can have g of x plus sigma x as a common factor. So I'll be remaining with that and that items. So I'll have f of x plus sigma x minus f of x. Okay, and from this side plus f of x plus sigma x will be the common factor. So I will take that out, f of x plus sigma x, and those two will remain. That is g of x plus sigma x minus g of x. Okay, all right. Now remember, our main objective is to find the derivative of the product of functions. So we were trying to rewrite this numerator. So we are successful in writing, like reducing into a form that we can apply a principle of derivatives. So we can now plug it back. So now we can write d by dx of f of x times g of x equals to the limit as sigma x approach to 0 of that expression, okay, over sigma x. Okay, so that will be g of x plus sigma x, okay, times f of x plus sigma x minus f of x. All right, plus the limit as sigma x approach to 0 of f of x plus sigma x times g of x plus sigma x minus g of x. Okay. The whole over sigma x. So we have the whole over sigma x from here. Okay, but it's also possible to, we can go ahead and divide that independently. That's also possible. Okay, sigma x. Now you know what's going on here, so we can do that. Okay. All right. So this means d by dx of f of x times g of x equals, now from this expression, the limit of this expression here, or sigma x approach to 0, so that will be 0, and have g of x. Okay, so g of x, and the limit of that is the very definition of the first principle of derivatives for f of x. So that will be first derivative of f of x, plus, and again the same way, and as sigma x approach to 0, that will approach to 0, and you'll have f of x, and again that will be the definition of derivative of g of x. Okay, so times g derivative of x. Okay, we can rewrite this by using the notation of d by dx. So d by dx of f of x gx equals d by dx f of x times gx plus f of x times d by dx of g of x. Okay, so therefore that is the product rule. All right, that's the product rule. Thank you for watching this video. I hope I'll see you in the next video. Please subscribe, share, and hit that bell. Thank you.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.